All right, everybody, welcome to Lesson 2's homework assignment. Coming to you here live from the APC room. So if you hear a little bit of background noise, I apologize for that. So let's take a look here at the first problem. So the first problem, a basic straightforward division problem, no missing terms or anything like that we have to deal with. So let's take a look. So first thing I'm going to do here is I'm going to put my 2x and my minus 3 on the one side so I can start to make my tabs. And I know that the first term is going to become 2x cubed. So if I have 2x cubed in that first box, I know I need to multiply x squared to that 2x to make 2x cubed. So now let's start to fill in our puzzle. So we have x squared and negative 3. That's negative 3x squared. Well, that has to add to something to make positive x squared. So now I have to think, well, what adds to negative 3 to make positive 1? Well, that's going to be positive 4. So I'm going to put 4x squared here. Well, to get 4x squared from 2x, I need to put another 2x up here, which makes negative 6x down here. Well, the next term I need to make is negative 16. Well, so these two have to add up to negative 16x. I already have negative 6, so I need negative 10 more, which is going to give me negative 10 here. Negative 10, sorry, I actually even did that in class, I think, today. So we have negative 5, right? Because negative 5 times 2x makes negative 10x, and then that gives us our 15. So for today's lesson, and actually for the foreseeable future, we're not going to deal with remainders. So an easy way to check is this number should be the same as this number. So we know that our final answer here winds up being x squared plus 2x minus 5. That and the denominator wind up being the factors of the cubic polynomial in the numerator of that fraction. All right, so let's take a look at the next one. So the next one's a little bit different because of a lot of missing terms in that numerator. So if you look at what we're dividing by, yes, we have our x cubed like always, so we have something to start with there. So I know I'm going to put x squared up here. But there's no x squared number, so you see how I have negative 2x squared here when I start my multiplication? Well, I don't want any x squareds. I want 0 of them. So if I want 0 of them, I need to put a positive 2x squared here so that those would cancel. Kind of like the issues that we saw, that pattern that we saw in lesson 1. So now we see that to make 2x squared, I need to multiply by 2x, which is going to make negative 4x. Well, again, I don't have any x's, so these have to add up to 0x, making this box 4x. Well, if that's 4x, I'm going to put a 4 here, and then I wind up having negative 8 on the bottom. So I can see that my answer to this question winds up being x squared plus 2x plus 4. All right, let's take a look at one that just has more terms. All right, again, I know I even said this possibly in class. It's not that this question is more difficult, it's just more steps. So there's more things to think about. So we're going to start here with our 3x squared. I'm going to put in my placeholder of 0x since I don't have an x term, and negative 1. And I know that my first term here is going to be 3x to the 5th power, so that makes this just x cubed. Now, I think somebody in class even might have asked me, how do I know how many columns there are going to be? Well, if this is x cubed, I know I need a column for x squared, for x, and for a number without x. So that's kind of how I know this is going to be 4 columns. Again, like I said in class, you don't need to do that. You can kind of just go along with it until there's nothing left to do, until you get that negative 2 at the end. All right, so if that's if that's x cubed, I know this is just 0. Actually, this whole row is going to wind up being 0, but if we don't put that placeholder in, everything gets kind of messy. This becomes negative x cubed. All right, so first thing I want to do now is these two boxes have to make 12x to the 4th power. Well, that means I need to put 12x to the 4th power in here. Meaning I need to multiply that by 4x squared. Because 4x squared and 3x squared makes 12x to the 4th, making this last box 4x squared negative. The next term I want to create is x cubed. So I need 11x cubes. Right now I have -1, so if I add 12 to that, that becomes positive 11x cubes, which means that that needs to be multiplied just by 4x. 4 times 3 makes the 12, x times x squared makes x cubed. Bring that down, -4x. All right, the next term we need here is the x squared term. I know the x squared terms come out to be 2x squared. Well, -4 and +6 makes 2. So then we could say that that multiplies by 2, which makes this -2, which, like we said, should be that last number, which it is. Meaning, when divided, this answer comes out to be x cubed plus 4x squared plus 4x plus 2. And we're almost there. So let's look. If we start here with 2x and 1, start to make our tabular setup. I know the first term needs to be 4x squared, which means I need to multiply 2x and 2x to make 4x squared, making this 2x. All right, well, I don't want 2x. I want a total of 8x. So if I already have 2, I could add 6 more x's. That'll make my 8x, which makes this a 3. 3 times 1 makes 3. And again, we see that this number is the same as this number. So we wind up seeing that this is also going to be our final answer. Now, one of the things that's interesting here, and one of the things that we will start talking about later on in this unit, is when you divide something by a expression like 2x plus 1, and it comes out to have no remainder, these are what are called factors of this polynomial. So what we could actually say here, and I know the question's not asking us to do this, but we'll go a little bit deeper here, is that this expression has factors of 2x plus 1 and 2x plus 3. We kind of started to talk about that in class today, but those are the kind of things that we want to start thinking about. All right, number 2. So for number 2, we have to go, you have to go through here and continue to find these divisors. So we're first computing this division, and then we're expressing it as a product of two polynomials. This is just a fancy way of saying factors. Right? So we just want to find the factors of this polynomial is essentially what they're really asking us to do. So let's start by dividing. So we have 3x, we have -2, and we'll do our normal division like we've been doing. I'm actually going to erase this so we have room, and I'll just write it up here. This means factors. And we can start out by making that 3x cubed term. So we're going to have 3x, so I know I have to multiply that by x squared, which makes this -2x squared. Well, I need 10x squared as my total. So to make 10 with a -2, I need 12. So I have 12x squared. So what multiplies by 3x to make 12x squared is 4x, which makes this -8x. Then we have to think, well, I don't want -8x, I want -14x. So I got to put another -6x in there to make that work, which makes this -2. Which makes this final box +4. Again, a quick check for now. Those match, so we're good. Now, if you did all of this work, and this would say a question on a test or even the Regents exam, you didn't finish, because it says to express the answer as a product of factors, or two polynomials. So what we have to say then is this polynomial, 3x cubed plus 10x squared minus 14x plus 4, is equal to 3x minus 2, the factor we divided by, times the quotient that we found, x squared plus 4x minus 2. This is the answer they were looking for. I'm hoping this helps. We're going to move on a little bit tomorrow in lesson 3, and we'll start talking about long division. So dividing with our process of long division that we learned way back when you were in 4th or 5th grade. Enjoy the rest of your night. See you tomorrow.